My esteemed viewers, in this tutorial, the router and its functional units of a router is clearly explained. It is important to underline the fact that the router is a very significant function performer in network layer. And a router, when we take the cross section of a router, we find the units, functional units represented something like this in the form of a block diagram. It has specifically 4 functional units. 1, the input port, 2, the output port, and in between comes the switching fabric, and the switching fabric and input port and output port are guided by a processor called routing processor. Now we will go on explaining one functional unit after the other with total completeness. Input port has 3 sub-functional units: the physical layer unit, the data link layer unit, and the network layer unit. It performs the physical layer function of the terminating and incoming physical link at a router, because you should notice that the router being a physical device, at the port there is a input channel or a wire, the terminal of a wire, terminal of a link just intruding into the router. Anyway, this should be identified or this should be sensed by physical layer unit of the protocol layer unit. And next comes, as the information moves in the bit form to data link layer functionality should be rendered on this coming information or coming packets or coming frame or whatever, and then it should be passed to network layer. An input port also performs, therefore the link layer functions needed to interoperate with the link layer at the other side of the incoming link. The lookup function is also performed at the input port. This will be done over here. Lookup function means looking at the forwarding table. That's all. In order to map the incoming datagram to output port, appropriate output port. This will occur in the rightmost box, that is this box, this portion of the functional unit of the input port. It is here that the forwarding table is consulted to determine the router output port to which an arriving packet will be forwarded via the switching fabric. The forwarding table is computed and updated by the routing processor with a shadow copy typically stored at each input port. And of course, the shadow copy will be sent to, you can see this over here, through this links. Routing processor will also provide shadow copies of the forwarding table so that this can readily refer, because it is an updated table. Network layer functionality of the input port can readily refer. Otherwise, this will avoid a huge time loss in referring to routing processor for every packet that arrives. Okay, this is avoided by providing shadow copies to the input port. The shadow copy typically avoids the forwarding table is copied from the routing processor to the line cards over the separate bus that I have shown just now. With a shadow copy, forwarding decisions can be made locally at the port itself, at each input port, without invoking the centralized routing processor again and again per packet basis, and thus avoiding a centralized processing bottleneck, thus avoiding possible delays in looking up at the table itself. So this lookup must be performed in nanoseconds, because the packets will be arriving at the line speed, at the speed of the input port or speed of the channel. Thus, not only must lookup be performed in hardware, but techniques beyond a simple linear search through a large table is also needed, because the arriving packet with its with its IP address being unfolded should be referred to the forwarding table in order to match the longest prefix match. In order to do this, a linear search is to be conducted, is to be implemented at the input port. Once a packet output port has been determined via the lookup table, the packet can be sent into the switching fabric. Switching fabric forms the heart of a router. It is said switching fabric forms the heart of a router because it is through this fabric that the packets are actually switched, that is forwarded from an input port to an output port. This is called as switching. Switching a packet, arriving packet just at the edge of the input port to the edge of the output port. Switching, there are three designs for this fabric. Switching fabric is so called because it is a typical circuitry through which the packets in the form of signals will move. Switching via memory is the first. It is an old method of design or old design technique, and it is simplest, of course. Earlier routers were transitional computers with switching between input and output ports being done under the direct control of CPU. It is nothing other than some kind of a CPU or some kind of a computer. An input port with an arriving packet first signaled the routing processor via an interrupt. The packet will then be copied from the input port into the processor memory. The routing processor then extracts the destination address from the header, looks up the appropriate output port in the forwarding table, which is resident of the memory, CPU memory, and copies the packet to the output port's buffers. Routers that switch via memory look very much like shared memory multiprocessors, and because there is a dedicated multiprocessor which is doing this kind of task of just mapping the input port to output port and copying into the memory, with the processing on a line card switching packets into the memory of the appropriate output port. And Cisco's Catalyst 8500 series switches called Cisco 8500 212 forward packets via shared memory, which looks something like this. Switching through bus is the second kind of a design. You can see here, this is the input port and this is the output port. There exists only one bus with a huge bandwidth. An input port transfers a packet. In this kind of a switching fabric, the input port transfers a packet directly to the output port over a shared bus. This bus is shared because every other packet coming from every input port should pass through or should find the channel in this bus without intervention by the routing processor. If multiple packets arrive to the router at the same time, each from different input ports, all but one must wait, since as only one packet can cross the bus at a time. This is the bottleneck with the bus kind of switching fabric. Because every packet must cross the single bus, the switching speed of the router is limited to the bus speed. So more the speed of the bus is, or more the data rate is, more will be the speed of switching. Therefore the bus capacity limits the speed of switching. And Cisco 5600 switches 2012 is provided with a 32 gigabits per second backbone bus. This is the switch in which this kind of bus switching fabric is provided. Crossbar switch. This is one of the efficient ways of switching the packets coming from input port to the output port. A crossbar switch is an interconnection network consisting of two N buses. N buses in this direction, horizontal direction, and N buses in vertical direction towards the output port, and these are all from the input port. So there are lines from the carrying the packets from the input line and moving towards the output line. Therefore, N buses horizontally, N buses vertically moving towards the output ports. So therefore, a crossbar switch will require 2N, an interconnection or crisscrossing of 2N buses. Each vertical bus intersects at horizontal bus at cross point. So every packet can cross over here. Therefore, all these points becomes the intersection of horizontal buses and vertical buses. which can be opened or closed at any time by the switch fabric control. So if a packet wants to move in this direction, there is a switch which should be opened by not allowing the packets to move further, only to take a turn in this direction, because a packet from over here, from B, is destined to go towards X. When a packet arrives from port A and needs to be transferred to port Y, the switch controller closes the cross point at the intersection of buses A and Y. Okay, and port A then sends the packet into the bus, which is picked up only by bus Y. So Y along this particular direction. Now, thus, unlike the previous two switching approaches, crossbar networks are capable of forwarding multiple packets in parallel. However, if two packets from two different input ports are destined to the same output port, of course, then one will have to wait at the input, since only one packet can be sent over any given bus at a time. This kind of switching fabric overcomes the limitation of a single shared bus and also the bandwidth. And Cisco 12000 series family switches use this kind of switching fabric, which looks something like this. And output ports, the important components, functional units, output ports. An output port stores packets received from the switching fabric and transmits these packets on the outgoing link by performing the necessary link layer and physical layer functions. Okay, if the input ports work in the order of a physical layer, data link layer, and network layer, the reverse ordering the functions of the rendered by the output port is in the reverse order, because it is the network layer component which comes first, and then data link layer, and then the physical layer. So it looks something like this. So the location and extent of queuing will depend on the traffic load, the relative speed of the switching fabric, and the line speed. Okay, and there is a differential speed as always, because switching fabric will always work with the speed of the input ports or input lines, or the speed of the channels. And here the output port cannot work with such a speed, because of the fact that every packet should be individually transmitted to the outbound link. Though the mapping will be over within no time, the transmission of each and every packet through the output port to the appropriate outbound link takes an amount of time which is equal to transmission delay. If lengthier the packet is, more will be the delay. Therefore, and since the queue forms different kinds of packets of different lengths, there is a differential transmission latency or transmission delay for each and every packet. Therefore, queues are formed. So therefore, this is the reason why queues are formed only at the output port. Since the output port can transmit only a single packet in a unit of time, transmission time, the n arriving packets will have to queue or wait for transmission over the outgoing link. Therefore, there is a buffer provided in the output port. It is okay. There are occasions where this buffer will be exhaustively filled up, and so much so that there won't be any space. In that case, packet losses will happen. So packet will be dropped. Okay, if the queue before an output port crosses a threshold limit, the arriving packets will be dropped. So output port, there is a responsibility for the output port that it has to maintain the queue. Okay, it has to make decisions about dropping, and it has to take decisions about selections of packets from the queue for transmission. Packet scheduler algorithm will do the task of selecting a arriving datagram for the transmission, for the further transmission. This selection might be done on a single basis, such as first come first served basis scheduling justifiably, or a more sophisticated scheduling algorithm has been the weighted fair queuing algorithm, which shares the outgoing link fairly among the different end-to-end connections that have packets queued for transmission. Let us say the first few packets are coming from one destination or one source, and the next packet, only one packet happens to be from different source. Therefore, this algorithm, sophisticated scheduling algorithm, will give a weighted fare for queuing. So possibly among the three packets from a same source, among them only one will be transmitted, and the other, which is waiting from a different source, will be given a chance to be transmitted. Therefore, the weightage here comes from the fact that what is the length of the packet, and is there any are the packets are coming from the single source. Okay, and these points are considered by this weighted fare queuing algorithm, so that every packet coming from different sources will be given some kind of an equal opportunity to be transmitted across the outbound link. Packet scheduling plays a crucial role in providing quality of service guarantees. There are packet dropping strategies also. When exactly a packet is dropped? Okay, of course the emphatic answer is whenever the queue is full. But of course there are algorithms called active queue management algorithms whose sole purpose is to decide the dropping strategy, the packet dropping strategy. Though there is an algorithm called random early detection algorithm, or RED algorithm, aptly called. Under RED, a weighted average is maintained for the length of the output queue. If the average queue length at every output port is less than the minimum threshold, that is minimum, when a packet arrives, the packet is admitted to the queue. That means if the queue length is lesser than the minimum threshold, then packet will be allowed to enter into the queue. Conversely, if the queue is full or the average queue length is greater than the maximum threshold, that is maximum threshold, then when the new packet arrives, the packet is marked and dropped. Finally, if the packet arrives to the find an average queue length in the interval maximum and minimum, the packet is marked or dropped with a probability. That means if the queue length is between minimum and maximum, then the packet will be dropped with a probability, typically some function of the average queue length, that is minimum and maximum threshold length. Is it possible, is there any occasion for the queues to be formed at the input ports? Yes is the answer. Okay, here is a typical situation at the input port. Two packets or two datagrams are waiting or to be ported to this output port, and this particular datagram is waiting to go over here, or this is destined to port number 3, these two are destined to port number 1. Here two packets, one the dark blue packet is destined to go over here, and this packet is destined to go to port number 2. These two will go, this has to wait, then this will go. Though this packet has no barricade, no obstruction, though for this particular packet the destination output port is this, which is empty, which is not being requested by any packet, it has to wait unnecessarily because its journey forward is blocked by this the packet which is in front of this particular packet. So that means though an output port is free for this particular packet, it is being blocked by another packet, okay, which has to move to some other port, okay, which is at the header, which is in front of this. This is called as head of the line blocking. So whenever such situations arise, definitely queues will also be formed at the input port. So this is the situation, it has gone and this will be going and this will also be going. Until then it has to wait, though its destination port is this one, though it is entry, though this is empty and it is not, there is no contenders as far as this particular port is concerned. Two packets darkly shaded at the front of their queues are destined for the same upper right output port. That's what I explained. Suppose that the switch fabric chooses to transfer the packet from the front of the upper left queue. In this case, the darkly shaded packet in the lower left queue must wait. But not only must this darkly shaded packet wait, so too must the lightly shaded packet that is queued behind that packet in the lower left queue. Even though there is no contention, there is no demand for the middle right output port, that is the central output port, which is the destination of the lightly shaded packet. This phenomenon is known as head of the line blocking. The next one is the routing processor unit. The routing processor unit executes the routing protocols, maintains the routing tables, and attached the link state information, and computes the forwarding table for the router. It also performs the network management functions. Often and often, whenever the routing forwarding table is updated, it's going to provide this forwarding table along the lines to the input ports, network layer functionality of the input port, and these copies of the updated forwarding table is called as shadow copies. So with this, we have completed another part of the network layer, the major functional component of the network layer, namely router. So in the next tutorial, we will bring up with some of the important protocols which are resident of network layer. Until then, bye. And if you like this video, kindly subscribe. This is my request with the viewers.